Okay, so this is going to be problem number 15 of the Grind 75. This one is called First Bad Version. We are given 20 minutes, so let's start the countdown now. Okay, let's see. First Bad Version. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check, since each version is developed based on the previous version. All the versions after a bad version are also bad. Okay. Suppose you have n versions, 1, 2, through n, and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API tool, isBadVersion, which returns whether version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. Okay, so I think this one was key. Since each version is developed based on the previous versions, all the versions after a bad are also bad. I'm actually just going to put that note right here. Um, let's see. N versions. Input is n, bad is equal to 4. So, okay, we'll have positive reals, seems like. Will there always be a bad? Will there always be a bad version? Let's see. Implement a function. So, I mean, what this, okay. So, okay, let's look at the constraints. 1 is less than or equal to, so there will always be a bad. We can be very big, 2 to the 31 minus 1. So this definitely seems like a binary search kind of algorithm. So as we know, that will be O of log n. And I will actually start off by making that implementation first. So let's see. We have our max and we have our min. I'll just say int upper val is equal to n, int lower val is equal to 1, and we can say it's kind of like a two-pointer thing. We sort of did a question like this before. So we can say while upper val, or let's say while lower val is less than or equal to upper val, we can change them until we find the one that's in the middle. So we'll get in the middle value, which will be, because we don't want to have this integer overflow error, we're going to take the average in a slightly different way. So the average between two things is, we did upper val plus lower val, divide that by 2. But to prevent an overflow, we're going to do lower val first, and then we're going to do upper val minus lower val, divide that by 2. And algebraically, these things are the same thing. If we subtract half out of this, then that becomes lower val divided by 2 plus upper val divided by 2, which is the same thing as this. So we're going to use that, or going to use that as the middle value. Okay. And so let's see. We want to find the first bad one though, right? So how do we find the very first bad one? We have to know that the one that is directly to the left of it is good. So we want to find the first bad one. Or do we want to find the first good one? This is, yeah, it's not as straightforward as I initially imagined it to be. We want to find two or just one. So, I mean, we can start off version control public and first bad version. So we can just use is bad version, yes. Okay. So I'm just going to check if n is equal to 1, then we can return, what are we returning? An integer, we just return 1. So how do we find the spot right where the first bad one is next to the first good one? So, okay, brute force, iterate through, but then again, could be like the very last one. So, if we had, let me go over to the drawing board actually really quick. Let's just think about this. So, I'm going to draw out BST really quick. So, say we had, let's use nicer color, 7, and then maybe we had 3, and then we had 11. This one goes down by 2, this one goes up, down by 2 would be 9, 13. This is probably a little bigger than we need to make it, but I'm just going to flesh it out. 4 and 6. And I'm just going to leave that for now. So let's say we have this array 0, 1, 2, 3, 4, all the way up to basically until we reach the end of the screen. So let's just say 11. Okay. Let's say our first bad value is, let's make it 4. Okay, so if we're going to use a binary search approach, and we know that 11 is our max, we're going to take the average, and we're going to get 5.5, which will give us 5. And we will see that this is a bad because everything after it is also bad. So I'm just going to say this is good and this is bad. Okay, so we know 5 is bad. So then we're going to, again, look in the middle of 5 and 0 and see that 5 is, or take the average of that, so 2.5, which will give us 2. Let's see, that's good, so then we're going to want to move 0 up, but we don't need to include that. And average of 3 and 4 is 3.5. 3.5 will also give us good. Until there's one value left. These are equal. So is it true that as soon as they converge, we will get the correct bad value? It seems like it, actually. So as soon as upper and lower, so we can just say as soon as it's less than, because they will eventually converge. Okay, that seems to hold up, so I'm just going to implement it accordingly. So switching over to the LeetCode window, like this, get our middle. We're just going to check. So if, let's see, if middle, if is bad version of middle is true. So if we know that's a bad version, then it's too high up, or it might be too high up. Let's actually go back to the drawing board and think about the extreme case where it is 11. So say we take the middle, it's good, then we're going to take the middle of that half, we're still going to get good until we get to the top. Yeah, so it just seems to be a binary search algorithm. So let's do that. So if is bad version middle, then that means that we are too high, and so we want to make lower val equal to middle minus 1. But let's say, do we want it to be middle minus 1? Because what if middle is, well, let's see. So if we were to take the middle of the illustration, 0 and 11, that would be 5, right? And if we, that is the first bad one. But then if we make the upper bound one less than that, then we won't ever converge. However, so let's say we keep going. So then we're looking at 0 and 4. Average is 2. 2 is still good, so then we're going to move up to 3 and 4. Average is 3.5. That's still good. So sorry, let me back up. So we have 5. We have that it's bad, and so we're going to move our upper bound to a value that's 1 less than that. Then we're going to take the average of that and get 2. C2 is good, and so we're going to move our lower bound to 1 above that. So now our upper bound is 4 and our lower bound is 3, and we are going to take the average and get 3.5, which gives us 3, which is still good. And then we're going to move that up to 4, take the average, the middle is 4, see that that's good, and because it's good, we're going to move the lower pointer 1 up. And at that point, we will exit the while loop, and we will return where lower pointer is, which should be 5, because we will have moved it up by 1 spot. Okay, so that seems to work out. So having considered several cases, I will just finish the implementation. Else if is bad version let's see. Can we just do else actually? Else upper val is equal to middle plus 1. No. We want upper val here to be middle -1, and then we want to boost the lower val. Okay, and then we want to return lower val. Okay, and that seems to work for me. Upper val, lower val. Again, we're taking the average this way because we want to avoid Java integer overflow error. If, let's see, bad version is that one that we picked that's in the middle of all our values, then we're going to move it one below that middle. Otherwise, we're going to move it lower, one up. And for as long as lower is less than or equal to upper. So, okay, let's think about the original case actually where it's 4. So 5 is our middle, 5 is too high, 5 is bad, so we're going to move it down to 4 as our upper. We're going to take the average between 0 and 4 to get 2 as our new middle. And we're going to see that 2 is good, so we're going to move our pointer up 1 to 3. Right, yes, to 3. See that, take the average of 3 and 4. See that 3 is good still. So we'll move the pointer up. And it seems like if the values are equal, if lower and upper are equal, and they are bad, then we know we found our value. But if it's still good, then we'll have to go through the normal logic. So we can say up here, if lower val is equal to upper val, and it's the case that lower val is bad, either of them really, is bad version, say lower val, then we can return lower val. Otherwise, if it's still good, but they're equal, then we can move lower val up appropriately. Because middle will not be, the average between these two numbers will be 4. So middle will be 4, middle will be good. And so we'll move it up and then we'll return that. Okay, that seems to work for me. I'm going to run the test case really quick. Okay, let's submit. All right, success. So yeah, that was a nice problem. That was like the right amount of difficulty for me. Too bad that that right amount of difficulty is me having already seen basically the solution to this and just having to think of some slight alteration. But We're going to go over this in the solution again, but I'm also going to look at some others to see if there's a better way of solving this. And I actually forgot to switch over, so let me just explain really quick what I did. So I did the typical binary search thing, but I was having that struggle between 4 and 5, and this is how I solved it. We'll talk about it more in the solution, so let me stop right here.